Aluminum conductors present several advantages. Firstly, cost savings, as aluminum is significantly cheaper than copper, offering cost savings in both material and installation. Secondly, they are lightweight, making transportation and handling more manageable. Thirdly, aluminum boasts an abundant supply, mitigating supply chain risks and price volatility. However, aluminum conductors also have disadvantages. Firstly, they exhibit lower conductivity than copper, necessitating larger wire sizes to achieve the same current capacity. Secondly, aluminum is more susceptible to corrosion, especially in humid or high chloride environments. Thirdly, their resistance increases more rapidly with temperature compared to copper, potentially leading to overheating and reduced efficiency. Conversely, copper conductors offer their own set of benefits. Firstly, higher conductivity is a key advantage, allowing for smaller wire sizes and reduced voltage drops. Secondly, copper demonstrates excellent corrosion resistance, making it suitable for applications demanding long-term durability. Thirdly, copper maintains its electrical properties at higher temperatures, ensuring reliable performance in demanding environments. Despite these advantages, copper conductors also have limitations. Firstly, they are more expensive than aluminum, resulting in increased material and installation costs. Secondly, copper is heavier than aluminum, which can be a drawback for overhead applications or when transporting large quantities. Thirdly, copper is a finite resource, potentially leading to supply constraints and price fluctuations. Alcan Stabiloy is a high-strength aluminum alloy developed by Alcan. It offers improved mechanical properties compared to standard aluminum conductors, making it suitable for overhead applications and other demanding environments. Key features of Stabiloy: firstly, it has high tensile strength, providing resistance to breakage and mechanical stress. Secondly, enhanced corrosion resistance compared to standard aluminum conductors. Thirdly, improved creep resistance, reducing elongation under load and maintaining conductor integrity over time. Fourthly, higher conductivity offers higher conductivity than standard aluminum conductors, reducing losses and voltage drops. When considering aluminum versus copper for low-voltage systems, one must carefully weigh the pros and cons of each material based on specific application requirements. Cost is often a primary driver, with aluminum offering significant savings upfront. However, the long-term performance and reliability of the system should also be taken into account. The lower conductivity of aluminum necessitates larger conductor sizes, which can offset some of the cost savings, particularly in applications where space is limited. Furthermore, the increased susceptibility of aluminum to corrosion must be addressed through proper installation practices and the use of appropriate connectors and joint compounds. Copper's higher conductivity and corrosion resistance make it a more robust choice for demanding environments where long-term reliability is paramount. However, the higher cost of copper can be a significant barrier, especially for large-scale projects. Stabiloy represents an attempt to bridge the gap between aluminum and copper by offering improved mechanical and electrical properties compared to standard aluminum alloys. Its higher strength and corrosion resistance make it a viable alternative for certain applications, particularly overhead lines where mechanical strength is critical. The choice between aluminum and copper conductors ultimately depends on a variety of factors, including cost, performance requirements, environmental conditions, and the specific application. A thorough evaluation of these factors is essential to ensure that the selected conductor material meets the needs of the system while remaining cost-effective. In some cases, a combination of aluminum and copper conductors may be the optimal solution, with aluminum used for the main feeders and copper used for branch circuits or critical loads. This approach can leverage the cost savings of aluminum while ensuring the reliability and performance of critical circuits. Understanding the specific characteristics of each conductor material is crucial for making informed decisions about conductor selection. Engineers and designers should consult relevant industry standards and guidelines such as the National Electrical Code, or NEC, to ensure that conductors are properly sized and installed. Proper installation practices are essential to prevent premature failure of conductors due to corrosion, overheating, or mechanical stress. Aluminum conductors, in particular, require careful handling to avoid damage to the oxide layer, which protects the conductor from corrosion. The use of appropriate connectors and joint compounds is also critical to ensure a reliable electrical connection. In addition to the material properties of the conductors, the overall design of the electrical system can also impact its performance and reliability. Factors such as voltage drop, fault current, and harmonic distortion should be carefully considered to ensure that the system operates within acceptable limits. Voltage drop can be a significant issue in low-voltage systems, particularly when using aluminum conductors. The larger conductor sizes required for aluminum can help to mitigate voltage drop, but it is still important to carefully calculate the voltage drop in each circuit to ensure that it remains within acceptable limits. Fault current is another important consideration, as it can impact the size and type of overcurrent protection devices required for the system. The higher impedance of aluminum conductors can limit fault current, which can be an advantage in some cases, but it can also make it more difficult to coordinate overcurrent protection devices. Harmonic distortion can also be an issue in low-voltage systems, particularly when using non-linear loads such as electronic ballast and variable frequency drives. Harmonic currents can cause overheating of conductors and equipment, as well as interference with sensitive electronic equipment. The use of harmonic filters and other mitigation techniques can help to reduce harmonic distortion and improve the overall performance of the system. The selection of conductors for low-voltage systems is a complex decision that requires careful consideration of a variety of factors. A thorough understanding of the properties of aluminum and copper conductors, as well as the specific requirements of the application, is essential to ensure that the selected conductors meet the needs of the system while remaining cost-effective and reliable. Remember that electrical codes and standards are constantly evolving to reflect new technologies and best practices. Therefore, it is important to stay up to date on the latest requirements and recommendations to ensure that electrical systems are designed and installed safely and effectively. For example, the NEC Section 310.15 provides guidance on conductor ampacity, taking into account factors such as conductor size, insulation type, and ambient temperature. NEC Table 310.16 lists the allowable ampacities of insulated conductors rated up to 2000 volts, based on an ambient temperature of 30 degrees Celsius and no more than 3 current-carrying conductors in a raceway or cable. Adjustments must be made to these ampacities for different ambient temperatures and the number of current-carrying conductors in a raceway or cable. For aluminum conductors, it is important to use connectors and joint compounds that are specifically designed for use with aluminum. These connectors and compounds typically contain an oxide inhibitor that helps to prevent corrosion of the aluminum. It is also important to avoid mixing aluminum and copper conductors in the same connection, as this can lead to galvanic corrosion. When connecting aluminum and copper conductors, it is necessary to use a transition connector that is specifically designed for this purpose. These connectors typically consist of a copper lug that is mechanically bonded to an aluminum lug, with a barrier between the two metals to prevent galvanic corrosion. In addition to the selection of conductors and connectors, proper installation practices are also essential to ensure the reliability of electrical connections. Conductors should be properly stripped and cleaned before being inserted into connectors, and connectors should be tightened to the manufacturer's specified torque. Over-tightening or under-tightening connectors can lead to premature failure of the connection. Regular inspection and maintenance of electrical connections can also help to prevent problems before they occur. Connections should be checked for signs of corrosion, overheating, or looseness, and any problems should be corrected promptly. In summary, the selection of conductors for low-voltage systems is a critical decision that requires careful consideration of a variety of factors. By understanding the properties of aluminum and copper conductors, as well as the specific requirements of the application, engineers and designers can ensure that the selected conductors meet the needs of the system while remaining cost-effective and reliable. Proper installation practices and regular maintenance are also essential to ensure the long-term performance and safety of electrical systems. When it comes to conductivity, copper reigns supreme, boasting a higher electrical conductivity compared to aluminum. This translates to smaller wire sizes for the same current capacity, minimizing voltage drops and maximizing efficiency. However, aluminum is more susceptible to corrosion, especially in harsh environments. Special precautions like proper insulation and joint compounds are necessary to prevent premature failure. Remember that aluminum's resistance increases more rapidly with temperature, potentially leading to overheating and reduced efficiency. Copper, on the other hand, maintains its electrical properties at higher temperatures, ensuring reliable performance in demanding environments. Copper wins in corrosion resistance, making it ideal for applications where long-term durability is crucial. Aluminum is more prone to corrosion, especially in humid or chloride-rich environments. Alcan Stabiloy steps in as a high-strength aluminum alloy designed to bridge the gap. Its enhanced mechanical properties make it suitable for overhead applications and demanding environments. Stabiloy offers improved creep resistance, reducing elongation under load and ensuring long-term conductor integrity. It offers higher conductivity than standard aluminum conductors, minimizing losses and voltage drops. Making the right choice hinges on carefully balancing cost savings with long-term performance and reliability. Consider the specific application requirements and environmental conditions before making a decision. Always adhere to the National Electrical Code, or NEC, guidelines and industry best practices for safe and effective installations.